Hey everyone, thank you so much for joining us today. My name is Monica Lee, Marketing Director at Viscosity North America. We're very excited to co-host with NYOUG for today's webinar. I'm so glad you could join us. A few housekeeping rules before we get started. You should have a Q&A chat box where you can ask today's speaker, Maria, anything you want. It is a live webinar, so please take advantage of that. She'll get to your questions as she can or at the end of today's presentation. Today's presentation is also recorded, so you will get access to that later today after it's finished rendering, as well as Maria's slide deck. So just look for an email from Katie Barnes, one of my colleagues at Viscosity. She'll tell you how you can access everything through orapub.com. So with that, I'm going to turn it over to Coleman, who's going to tell us a little bit about NYOUG.
Thank you very much. Welcome to our co-hosting sessions with the Viscosity Group. And we have Maria speaking today, and I'll get a little bit about Maria in a moment. So New York Oracle Users Group was formed almost 40 years ago for the exchange of ideas, assistance, and support among users of Oracle software products. And we're always looking for abstracts, and we'll co-host with Viscosity for anything that says Oracle in it. Must be of a positive nature, and we'll go forward from there. So you can connect with us on Twitter, Meetup, and of course the abstracts, LinkedIn, Facebook, and our website, nyoug.org, where all these presentations for the past 18 months are kept, as well as the MP4s, PowerPoint presentations as well. And I want to thank once again for Viscosity North America for co-hosting these series of webinars with us, and also for Maria Colgan for speaking with us today.
Awesome. Thank you, Coleman. All right. And I know you want to hear from Maria, but I've got a few more things to say. If you're not familiar with Viscosity, I'm just going to give you a quick little rundown about who we are and what we do. We are an Oracle partner, and we work very closely with a lot of Oracle product management. We've got 5 Oracle ACEs on our team. They're amazing. Hopefully you've seen them at different user groups and conferences around the States. And many Oracle customers are increasingly relying on professional service partners like us, where we serve as trusted advisors to help you make better purchasing decisions. Our business mode at Viscosity is simple. We work hard to build trusted relationships with you, and we implement technologies and solutions when the time is right. And we're always happy to be a resource for you, whether that's tomorrow, next year, or later down the road. And it's pretty simple right here. If you're looking at my screen, we are based on these 3 pillars: data, apps, and infrastructure. So if anything here sparks some interest, reach out to me or my colleague Katie, who you'll have an email from her later today, and we can get you started on a conversation with us and our team. A large bulk of our business is on the database side, and that includes data integration, data warehousing, zero downtime migration to the latest versions, including 19C. And overall, we help improve performance at the database level. In our applications practice, we actually do a lot of Apex development, EPM, ERP, and we develop custom apps. And finally, on our infrastructure and hardware practice, we include Oracle's public cloud offering, bare metal, engineered systems, and we are actually named Oracle's ODA Partner of the Year in 2019. So we're very active. We've always got events going on. We love participating in the Oracle community with people like Coleman and NYOUG and all of their followers. And here are some of our Oracle ACEs I mentioned. I think I'm actually missing one more who joined our team this year, Julio Ayapan, and he is based out of Guatemala, and he's a DBA. So like I said, we've got some great folks working for us. Hopefully you see them present, or you have seen them present their books. They're awesome, and we love to say there's nothing better than having 4 ACEs in your hand. Now we've got 6. All right, and this slide showcases some of our services. I'm not going to go over everything. As you can tell, we do a lot within the Oracle umbrella. So real quick, we've got a lot of folks on our team who are experts in Oracle license management and that have come from Oracle themselves. So they've been in that space for several years. They're very well versed and they're happy to help you make sure you make the right investments and get what you need to get. All right. And finally, this slide just kind of gives you a quick view of the books we've written. Our team has spent a lot of time trying to share their knowledge with users like yourself. Maybe you have some of these books by Charles Kim, Rich Nemick. We've got so many different books, I can't even keep count anymore, and now they're digital as well. So if you're interested in something here, definitely reach out to us. All right, and finally, if you like events like this, keep up with viscosityna.com/event. You can sign up through there, even if it's through an NYOUG webinar, it'll all be listed there as well. Follow us online for more information, and then Katie's email is right here. That's the email you wanna look for after today's presentation. All right, I'm gonna turn it back over to Coleman, and he's gonna introduce us to Maria.
Thank you so much. So Maria is a master product manager at Oracle Corporation, has been with the company since version 7.3 was released in 1996. Maria's core responsibility is to advocate for the Oracle database and the best practices for incorporating it into your environments. She's also responsible for getting the feedback from our customers and partners incorporated into future releases of the product. Prior to this role, she was product manager for Oracle Database in Memory and the Oracle Database Query Optimizer. Thank you again, Viscosity, and thank you, Maria, for presenting today on this series of webinars.
Thanks, Coleman. I'm delighted to be here to have an opportunity to talk to you guys about Oracle's converged database. And rather than spend the whole 50 minutes just talking about the technology, I really wanted to be able to show you that technology in action and show you how much value we can get from the data stored in Oracle databases. So during the course of the presentation today, I'm going to reach out to some of my fellow product managers to help showcase the technology I'm talking about in the form of a demo. And that demo is all based around MovieStream. And I'll give you a little bit more detail about MovieStream, which is a fictitious company, but you should hopefully be able to understand their particular business model and how all of the technologies I'm talking about today work together hand in hand to be able to make that business a success. So one of the things that we've noticed over the last 44 years that we've worked with customers at Oracle is that customers are under increasing pressure to maintain their competitive edge. They need to not only understand their customers, but they also need to be able to anticipate those customers' needs and be able to offer them the services they want before the customer even knows they want it. And the easiest way to do that is to become data-driven, or take advantage of data-driven applications. Now, data-driven applications are different to their traditional relational applications that we know and love today, because they're going to generate value from that data in very different ways. So for example, they may use machine learning in order to be able to do maybe fraud detection or product recommendation as someone is checking out of a particular order. You may also see them take advantage of graph analytics, where they're able to identify an influencer within a community and target that influencer with a specific marketing campaign. They may also take advantage of different types of data, whether they be document data or spatial data, perhaps to tell a customer where the closest store is to that particular customer, or track goods that are being sold or moved around. And all of that means that these new applications need to be fed, of course, on a lot of real-time, up-to-the-minute data that's often pulled from multiple different systems. However, you may be surprised to know that in a recent survey, 75% of companies are actually failing to become data-driven. And it's not because they can't gather the data that they need. The problem comes with being able to generate value from the large volumes of data that these companies are being inundated with. So what I want to talk to you today about is how we can help you become data-driven by helping you take advantage of the technologies that are built into the Oracle database today. The database that you already own, there's no additional cost on anything that I'm going to talk about. I want you to be able to get better value and innovate more with the data you already have in your Oracle database. And Oracle's converged database allows you to do that, because rather than having lots of specialized databases, one for each different data type or data model, Oracle offers you a converged database. And that term really encompasses multiple things. It encompasses it being a multi-model database, multi-workload, easy to use, and also containerizable. That's really what we mean by a converged database. And why do we use that term? Because Oracle is quite unique in the fact that not only does it support all of these different data models, whether you want to use relational or JSON data or spatial or graph, but we've engineered them to work together. So you can run simple SQL or REST APIs across all the different data models to get better synergy or better value out of that data. And because the Oracle database is a multi-workload environment, or one that can support all of these different workloads, you can use it not only as transaction processing or for data warehousing and analytics, but actually for a mixed workload environment, one where you're going to do transaction processing and analytics simultaneously. Because in fairness, to become data-driven, that's often what you need, is to do some real-time analytics right there on the transaction processing system in order to be able to get that action on that data as fast as possible. And we make it very easy for you to do all of that. And as I said, we don't want you to think of the converged database as a big monolithic database where all of your business apps need to be using that same database. That's not what we are talking about when we talk about a converged database, because our converged database is modularized or containerized, if you prefer, making it very easy for you to have all of the agility and independence that people want these days with modern apps, especially if you're following a microservices architecture. You can do all of that with the converged database by storing each service's data in its own pluggable database. And that pluggable database can then either be in its own container database or co-located with other services in a single container database. And by placing multiple services in that one container database, you're able to manage many as one, which gives you a lot of key advantages. The other key advantage that's rarely talked about when people talk about microservices, but is incredibly valuable, is the fact that you can back up all of those databases in one. And more importantly, is you can restore them all as one. So if there is, for some reason, a need to restore your microservice architecture, rather than you having to manually sync the backups across lots of different independent databases, that synchronization is done automatically for you as part of the Oracle Restore. We can bring all the databases back to the exact same point in time and make sure that you have that very consistent view of the world across all of your microservices. Now, as I said, rather than listening to me talk on and on and on about Oracle technology, it's far more interesting for us to see it in action. And that's what I want to spend the rest of the presentation doing with you today. We're going to look at MovieStream. And MovieStream, as I said, it's a fictitious company, but one that we can all relate to, because it's supposed to be a streaming platform that streams unlimited movies to your phone, tablet, laptop, or even your home TV. So basically very similar to Netflix, Hulu, or any of those other streaming applications that you're probably used to today. And what's going on with this online company is that their customer base is expanding rapidly over the last 18 months, and that's generated massive volumes of both structured and semi-structured data. So they're storing some of the data in relational format. Others are coming in as JSON and XML documents, things like information about the movies, stuff like that is being stored in semi-structured data. And throughout the rest of the session, what we're going to do is we're going to use that data set to demonstrate how the Oracle database can quickly and easily help MovieStream capitalize on this raw data. We want to help them gain better insights into their customers, enhance their customer experience, and ultimately improve their profitability. And as I said, rather than listening to me for the full rest of the hour, I've got some of my colleagues here with me. Marty Gubar will help us with our data set. Marcos will help us get better insights into that data set. And then Jananth and Melly will help us with the marketing campaign that we're going to build with this. So over the next few minutes, we'll look at relational and JSON data as well as spatial data. We'll look at machine learning, graph, time series, and even text search on this data set. So as I said, the MovieStream folks are using the Oracle database not only as a relational database, but also as a document store. And Oracle makes it incredibly simple for you to be able to store and gain value from JSON and XML documents that are stored in the database. One of the most obvious ways to get that value, of course, is that you can freely mix JSON and relational data, not only in the same database or schema, but actually in the same table. And in the example here, that's exactly what we're doing. We're storing relational and JSON data within the same table. Now, as the volume of JSON documents grows inside in your database, one of the problems that can occur is being able to understand exactly what data you have. Remember, with JSON documents, there is no predefined schema. The schema is actually stored as part of the document. And so as that volume of documents grows, it can be tricky to keep track of exactly what data you have. And Oracle makes it very easy to be able to resolve that by offering you a built-in native JSON data guide. What that does is it runs out, looks at all the JSON documents that you've got stored in the database and reports back exactly what elements or attributes are stored in each of those JSON documents. It tells you exactly what data types are being used, so you can get a full understanding of your schema. And if you're working with kind of folks that are very SQL centric and really want to view that data in a more traditional format, that's no problem. The data guide can also create virtual columns on the tables that store the JSON documents, and they can be virtual columns on each of the individual attributes inside in the JSON documents, making it much easier for traditional SQL developers to be able to access, query, and generate value from all of that data, because they can just access those virtual columns. Under the covers, Oracle will extract the appropriate information from the JSON documents. Now, because they are built in so seamlessly into the Oracle database, when you store JSON inside in the database, you get all of the benefits of full ACID transactions. You also get the benefits of our performance improving features, things like indexes. You can index the individual elements inside in those JSON documents, making it much easier to be able to join and aggregate on individual elements inside in the JSON. And we'll see that in just a moment when Marty shows us the demo. As well as being able to index it, if you are doing analytics, you can use parallel execution to run large queries across all of those JSON documents and relational data or spatial data simultaneously. And because you can have it all inside in the Oracle database, there's no need for you to write custom application code in order to be able to do the basic management tasks. All of that happens automatically because it is inside the Oracle database. So let me hand you over to Marty now, who's going to show you just what kind of data we've got in the MovieStream database and how we can begin to just use simple SQL to be able to get some value out of that data. Actually, I'm very sorry. I just realized I need to share in a slightly different way so that you guys can hear it. Sorry about that. Let's try this again. You probably won't be able to hear Marty. All right, let's try Marty again.
Very much, Maria. So we're going to start by looking at a very simple thing, right? What are my customers doing? What kind of movies are they watching? And so we're looking at, let's say for double income, no kids, they're very interested in dramas. divorced and widowed folks are probably more interested in maybe less so. We want to compare that to comedies, et cetera. So you're looking at across our different customer segments, what types of movies are they interested in watching? And when I look at the query behind this, right, here's the query that we've run. So now how does that compare to last year? Right. And probably this is a better example of, COVID versus is not COVID. So I think people are very interested in, more interested in dramas and what else do we have? A romance, and probably less so in comedies. And I think that kind of reflects what I've been doing. I haven't been watching many comedies. I don't know why. So rich time series capabilities. Here we're using a lag operation to be able to do a year-over-year comparison of our revenue and what people are actually doing in terms of the types of movies that they watch. Now, we also, as part of multi-model, have different data types, as Maria was describing, right? So JSON is a very popular choice. It's extremely flexible. Here I'm seeing for each of my movies, these are the awards that they've won. Right, so here we're looking at, this is kind of a standard relational view, but then the awards coming from the same table is actually an array, right? This is a JSON array. So I can see 12 Years a Slave has won many, many awards. And this is all coming from the same table, right? So I have a movie table which is showing both the movie titles and the awards that they've won. Pretty tricky to query. Right? This is a little more challenging. What we really want it to look like is something like this, right? This is more of a standard view that's easy to understand, right? And so for 12 Years a Slave, it's won an Academy Award for Best Picture, a BAFTA Award for Best Film. And if we compare that to our previous query, which had the JSON column, here we're doing a pretty powerful transformation that's doing a lateral join that says, okay, for each movie, let's see the actual awards. So you can think about it as exploding it. So now this is a view that I can understand. This is a view I can use as part of a subsequent query. And we're going to do that next, right? So now that I have the data in a way that I can actually analyze, oh, the Academy Awards is coming up. Can we expect more interest in Academy Award winning movies? So these are all Academy Award winning movies in the past. And we're looking at, well, let's look at 2 weeks before the Academy Awards and 2 weeks after the Academy Awards. And we can see that Amy and Sideways and all these movies, and we can see just generally for Academy Award winning movies, we see a nice bump after the Academy Awards. So we're actually combining our analytics, a time series analytic, across the different types of data that is stored, right? So now we're looking at, again, this is that JSON data, right? The Academy Award winning movies, and we're combining that with the analytic function to produce the before and after result. Right? So we took a complex data type, made it pretty simple to do a kind of a rich analysis over that. So let's pivot now. We're looking at data by movie. How about our customers? Do we have customers who are at risk? Let's do an analysis of our customers. And we're going to do an RFM analysis, recency, frequency, and monetary analysis, which says, okay, I'm breaking my customers into 5 quintiles, and my big spenders are number 5. So everything that's in number 5 is at the top. But what we're looking at here is big spenders and people who have come to our site frequently, but they're actually in the lowest quintile of coming to our site recently. So big spenders, it seems like we may be potentially losing them. Let's look at that SQL. And again, this is another time series analytic that we're performing that is breaking this up. And I'm just running it again, right? That's breaking this out into tiles, or quintiles by how much people spent, when was the last time they visited our site, and how frequently they traditionally have come. This is something that we're going to need to keep an eye on. Are we losing these customers? And for that, I'm going to pass it back on to Maria.
Awesome. Thank you, Marty.
Very much, Maria. So very much, Maria. So we're going to
We're
start by
stuck in
looking.
Marty. All right. So thanks, Marty, for that. And what we've discovered there from what Marty's showed us in the raw data is that our frequency of our top spenders coming back to the site is starting to drop off. So people who spend a lot of money, maybe 18 months ago at the start of the pandemic, streaming movies, are starting to fall off. And we want to find out why that is. And one of the things we can look at is whether or not they've left us any kind of feedback about the movies they've watched. Maybe we're not catering to their tastes anymore. And Oracle makes it incredibly easy to be able to search through feedback because we offer built-in text search capabilities inside in the Oracle database. So whether you're doing keyword searches, context queries, or trying to pattern match inside in that data set, we can easily allow you to do that. And we can also perform linguistic analysis on those documents to actually easily classify the feedback as positive, negative, or neutral sentiments. And because our particular feedback is stored inside JSON documents, we can actually use the structure of those JSON documents to narrow down the search for these particular keywords that we're after. So we can use the structure of the documents to restrict the search to just individual attributes inside those JSON documents. So for example, we can look for all the movies where in the comment field, the customer has left words, things like awful or disappointing. And in fact, it's super easy to do that. I just want to show you a quick set of steps, the 2 steps to do that, and exactly the code you'd need to do it. So you're going to create an index on our movies table. You're going to do it on the reviews column, which is JSON documents, a set of JSON documents, and you need 2 additional keywords. You're going to tell me that it's a search index, that we want to use this index to help find particular phrases or words inside JSON documents. So I say it's a search index for JSON. Oracle automatically takes care of everything else. Once the index is built, then I can search using that index for movies that where the review or the comment field inside the review contains the words awful and or disappointing. And I do it incredibly simply. I say I want to select the title and the comment for from our movies table, and I just simply do where the JSON text contains inside the reviews column, which is the JSON document, the actual attribute inside that I want to search for is comments, so the customer comments, and what I'm looking for is awful and disappointing. So anytime we see that, we'll be able to figure out if the customers hated the movies or not. Well, it turns out after we did that search, we couldn't find a correlation between bad reviews and these high spenders that may be leaving our site. So we're going to need a little bit more insight into why they're leaving. It's not the movies. So in order to do that, we're going to take advantage of something like machine learning, which allows us to do data-driven predictions. In other words, use machine learning to look at our historical data, understand and identify the pattern for these big spenders and why they may be leaving the site. And by building those models and training them with historical data, then they'll be able to help us predict going forward who are the at-risk customers and allow us an opportunity to rectify the situation before they churn or before they leave our site. And Oracle makes it incredibly simple for you to be able to take full advantage of machine learning in this way to do these data-driven predictions, because we have over 30 in-database parallel and scalable machine learning algorithms built right into the Oracle database. They'll allow you to do things like real-time recommendation, fraud detection, and this customer segmentation that we're after in our particular example. And what's great about it being built into the Oracle database, it means you can eliminate all of the costly and risky movement of data to a specialized machine learning engine, because your data stays exactly where you take advantage of these built-in capabilities inside in the Oracle database. And if you are lucky enough to have data scientists on your team who are perhaps more comfortable doing things like machine learning in R and Python, then our easy integration makes it super fast for those data scientists to use the database as a high performance compute engine to run those extended machine learning capabilities right there on the Oracle database. Now, machine learning was previously a priced option called advanced analytics. That's no longer the case. If you're running any supported version of the Oracle database, whether it's standard edition or enterprise edition, you now have access to all of these machine learning capabilities completely for free as part of your licensing. And for our less experienced users, there is, as part of our autonomous database, kind of quick start UI guide to machine learning that we call AutoML. That'll automatically determine the right algorithms and everything you need to use. And to take a look at that, I'm going to hand you over to Marcos, because it's really, really simple. And once you see it in action, you'll realize just how simple it is, because all you're going to do is tell Oracle, here's my data set. Here's the question I want to ask. And then it will automatically identify the appropriate algorithms and then fine tune the model that those algorithms help build until we can actually get you the best probability of predicting the particular business question that you're after. But as I said, let me hand you over to Marco, because he's going to show us exactly how to do all of this on our MovieStream data set.
Thank you very much, Maria. So I want to build on top of findings that Marty was understanding from potential customers, right, that were churning, right? So leaving the company and not stopping using the service. So I have here the tools then to do that, basically. As Maria was saying, I'm going to go into AutoML. So when I go into AutoML, basically I can create experiments. And the idea here is that it's very simple. So you create your first experiment, you give it a name, put a comment, and then just find the data source. Now, that data source is all the tables that have to do with, of course, the security, right, underlying my tables and my data. So I have a data that I have prepared. It's just basically joining the data that Marty was working on. So when I bring that information in, then AutoML is going to say, okay, these are the requirements that I have. So I have to tell it what is the target, what am I predicting, and then what's the case ID. So if I look at the data here, I have everything from customers, right? So the age, what is the application they've been using, how much money they've been spending with us in the last quarter, right? In the last 6 months, previous quarters, number of transactions, and then even, you know, city, commute, because I don't exactly know what kinds of features were going to pop up as important, right? So I have everything here, discounts given to customers in the past, all the way to genres of movies like Marty was showing, there are preferences, and all the way to maybe the most seen movies, right? The most watched movies, and especially all of these movies that people watch all the time, right? So at that point, then I have to say, okay, what is the actual prediction, right? What I'm trying to predict. So if I scroll all the way down here, I see there's a column called target, and that's my target. This is going to be, there are two distinct values for this column. This is, was a non-churner, right? So the customer is still with us, or the customer left. And I can see the mean here is 0.01. That means 1% of my customers have stopped using my service in the last month. So I want to know why, right? So that's the part that the machine learning can help us with. So I'm going to say, okay, this is my target. I'm trying to predict that 0.1. And yes, this is the customer ID. Now, I could just start my problem right there. I could just click start and then start the execution of that process, okay? So if I'm a non-expert, it's very simple for me to start that process. Now, if I am a little more expert or I'm a little more data mining and machine learning curious, I can, for example, open here the additional settings, and I can see, you know, how many models can I train. I might want to leave one type of model out if I don't want that specific type of algorithm to be used. And I can even choose what's the model metric that I'm trying to optimize. So at that point, you can execute it. So what I'm going to show you is one that was already executed. I have executed that just yesterday. And what you see here is after the model completes, right, it shows me what it did. So as Maria was pointing out, right, so we're going to do algorithm selection, we're going to do adaptive sampling, feature selection, and the model tuning for all these guys. And finally, we're going to finish with the prediction impact. In this case, this is the best model that is shown here. And so if I click on that model, I can see now the prediction impact specifically for this model, what were the most important attributes, right? So the model has attributes from the average transactions in the last 3 months, which makes a lot of sense, right? But also I have number of transactions. I have average spend on the last 6 months, which again makes sense. But then there are other things that might not have been, intuitive, like the guy uses Mac or an iPad, or maybe the person likes to watch genre war movies, all the way down to the discounts that I have given that customer in the past. So the good thing with this model then is actually I have a confusion matrix where it's showing me that I was able to detect all the churners, right? On this test data set, on the final test data set, I detected all the churners, so 17 out of the 17 churners, and I only misclassified one non-churner as a potential churner. So in fact, it's not really bad, because what I'm trying to do here is offers, right? So I'm trying to offer something to keep these people. And the only bad thing is I would have wasted some dollars giving that customer something, but it's not really bad. This is not a bad thing. To me, the worst thing would be to lose customers here, right? That I wouldn't have detected. So if I like this model, then the model is good. As a non-data scientist, I can just deploy the model. If I click on a button here, I can immediately deploy this model to as a service, to a REST endpoint. And that model is immediately available 24/7 and ready to roll and in real time. So with that, I'm going to give you back to you, Maria.
So thanks so much for that, Marcos. So what we've discovered is, even though we couldn't figure it out ourselves as humans, why these top spenders were leaving, the machine learning algorithms built into the Oracle database was able to determine exactly who is going to leave. And so by being able to give us that target group of at-risk customers, our marketing department has come up with a campaign to help entice those customers back to our site and make sure they don't leave. And what they've come up with is a free movie night on us. So what they want us to do is help them build this campaign that will give these at-risk customers a free movie that we can determine is a movie that will entice them to come back to our site, and also a free coupon, or a coupon for a free pizza at one of our local pizza partners that's close to that particular customer's home. So it would make sense for them to order that pizza and enjoy that movie night. So that's what our next task is. Now that we know who the at-risk customers are, the marketing department is asking for each of those at-risk customers, give me the right movie and give me the right pizza partner so that I can come up and auto-generate these email offers for those particular customers. And what's great is that the Oracle database can help you do both of those activities with built-in capabilities at no extra cost. Because with Oracle database, you get all of our spatial capabilities. So you can use location intelligent analytics and our mapping services to compute the distances between things like our at-risk customers and our pizza partners. You can also, of course, use this technology not just for this kind of analytics, but also to analyze networks, things like transportation networks or telecommunication networks, as well as utilities, or even just to define sales territories, which customer is next to which office or store, and so forth. And as I said, we've got hundreds of in-database spatial operators and functions built in to help you do all of these things. You can call them instantly through SQL. You'll see in a second how you can use our our UIs to do it. We're going to do it all through a graphical UI in just a second. But what I want to highlight here is, if you haven't taken advantage of our spatial capabilities, perhaps in the past, because it was a separately licensed option, it is now completely free. So if you're using 19C, 21C, whether you're using Standard Edition or Enterprise Edition, you can take advantage of all of these spatial capabilities for free inside in the Oracle database. But rather than listening to me talk about them, I'm going to hand you over now to Jananth, who's actually going to show us how we're going to use those spatial capabilities to find the closest pizza partner to each of those at-risk customers that Marcos helped us find.
Thank you, Maria. As Maria was saying, when loaded the data, there was some location information about the customers and partners, etc. And when Marcus created his customers at risk table, that obviously included the location information. Now we could see it from SQL Plus or any other as a list or any one of those notebooks, but being location information, it's better to view it on a map. So let's look at where those customers were. So this gives us a quick idea of the distribution of the customers at risk. Then the other thing that we've got is all the over 45,000 pizza locations, right? So that's the pizza locations. And the problem that we're trying to solve is find pizza locations that are nearest to these customers at risk, but we want those locations, or only want to look at those pizza locations that are actually a partner. So let's first filter by those that are partners. And then of these, we now want to do the query. Now, all of these operations, what we're doing over here is exposing all the possible operations that are there in the database as SQL, but just through a drag and drop interface. So the operation that I want to do here is find the nearest pizza location to my customer at risk. I'll set this off to run in the background because I already have those locations found. Let's zoom in, let's say out here. And that, for example, is a customer at risk. And that is the nearest pizza location, which happens to be a Pizza Hut. And with that, I will hand it back to Maria.
Thanks, Janant. So now we've done the first half of what marketing has asked us to do. We've found the nearest pizza partner to each of those at-risk customers so that we can send them a coupon that's going to make sense for them to order for their free pizza and movie night. So the next thing we need to do is determine what movie each of those at-risk customers would actually, what would entice them to come back to our site. And we're going to take advantage of built-in graph analytics for the Oracle database in order to be able to discover what those movies would be for each customer. Because what we're going to do is we're going to create a community of similar customers who've got similar movie watching styles or preferences. And then what we'll do is we'll use that community and the movies they've watched to determine what new movie this customer has yet to see that would entice them to come back to the site. And we're able to do that, as I said, using graph analytics because we have over 50 in-memory parallel graph functions available to you that you can access using our open source SQL-like query language that we call PGQL. But you can also do this through a graphical user interface. And Mele is going to show us that in just 1 second, how she's going to use graph to be able to determine what those movies are that these customers would enjoy watching and then be able to make those recommendations to entice them to come back. And of course, graph analytics, whether you're doing property graph or referential graphs or whatever it may be, you can do all of that for free inside in the Oracle database. Again, this was a previously priced option. It's now completely free in your 19C, 21C Oracle databases. So with that, let me hand you over to Mele, who's much more familiar with graph and much more of an expert than I am.
So let's start by creating a graph from the tables that we've been working with. So I'm going to use the Graph Studio feature of Autonomous Database and use automated modeling to create a graph from these tables. So I see here a bunch of tables, and I'm going to select a few of these tables to create a graph from these tables. And let me now get to my third table here. So, okay, I'm going to create a graph from these 3 tables: table of customers, table of movies, and information about who rented which movie. And I click next here, the automated modeler automatically identified which would be the vertex tables and which would be the edge tables based on the foreign key relationships between these tables. I can look at the source of the data definition for the DDL that we could use to create a graph. And if everything is good, I can go ahead and now create next. and then I can go ahead and create a graph. Once I've created the graph, I can then use this notebook to run queries on this graph and analyze this graph. So this is a graph of movies and customers, what we call a bipartite graph. And here I'm running the PTQL query that Maria just talked about, which now says for these two customers, find me all the movies that they both watched. So here are the customers and here are the movies that they both watched. And you can run other types of queries here for different type of visualizations in this graph. You can have a radial visualization here. You can have a concentric visualization of the same data set in the above paragraph and so on. So lots of different options here to view your graph. And then let's come to graph analytics, which is where we're going to look at the list of movies that we want to recommend to these at-risk customers. So I get a handle for this graph in memory. And then I'm going to look at what algorithms I can run. And you can see here that this graph has like 151,000 vertices and about 18 million edges. And now that I'm going to run a graph analytics query. So we have over 50 pre-built algorithms, and I'm going to here use the whom to follow algorithm. So if you're looking at two customers, it's kind of straightforward to figure out what movies you should recommend. For example, if Melly has watched several of the movies that Maria has watched, then it's likely that Melly will be interested in the movies that Maria has watched, but Melly has not yet watched. But what graphs allow you to do is to have a more complex set of relationships between customers and identify movies that that can be recommended based on that. So what this algorithm will do is it will create clusters of customers based on the movies that they're watching and based on the overlapping sets of movies that they've watched. And once and also does the clustering and also looks at the link structure within these communities of users to make recommendations for this particular customer that we are looking at right now, one of the at-risk customers. So now that I've run the algorithm, I can look at some of the information that is available. For example, here I have the cluster that this particular customer belongs to. These are the community of users that this customer belongs to. And based on the link structure within this community, the algorithm has identified the movies that can be recommended. And here I see a list of movies that can be recommended for this at-risk customer. So let me take one of this, The Lion King, and see what happens when I run a PTQL query against this particular, with this customer and with this movie to see whether there is a connection between these two entities. And we see here indeed that there are two paths between this customer we are examining and this movie, connected with a dotted line to indicate that the connection is not direct, but it's connected through various other customers that belong to the community. And if I look at another movie here lower down the list, Lady Bird, we see that there is a single connection. So there is a path, not a direct connection, but there is a path between this customer and this movie. And here there are two ways in which this movie is recommended for this particular customer. And with that, let me hand it back to Maria.
Thanks, Melly. Okay, so just to recap, before I show you the marketing campaign in action, what we've done so far in the presentation, we were able to use the built-in SQL capabilities of the Oracle database to be able to look at data stored in multiple data models. We looked at relational, JSON data, and even geospatial data to be able to get insights into our data and better understand our customers and anticipate their needs. We discovered that some of our customers, especially our high spenders, were starting to leave our site. And in order to be able to determine why that was and to be able to predict future customer churn, we employed the built-in machine learning capabilities of the Oracle database to be able to determine what was that pattern that indicated somebody might leave and be able to predict other at-risk customers. Once we had those at-risk customers set, we were then able to use the built-in spatial capabilities of the Oracle database to find the nearest pizza partner to each of those at-risk customers. Now we had the right pizza partner, we needed the right movie for those customers. And that's what you just saw Mele do there. She used graph analytics to be able to, first of all, put those at-risk users into a community of other viewers or other users of the site that had similar movie tastes. And then once we had that, we were able to work out what movies that community had watched that this particular at-risk user had not watched. That's why we wanted those dotted lines in the graph, indirect connections to those movies and those users, meaning that the user hadn't seen that movie yet, but everybody else or a majority of people in the community had seen that movie. And using all of that information, we were able to build that marketing campaign that we wanted to send an email to all of those at-risk customers, offering them a free movie night on us with the right movie to entice them back to our site and the right free pizza coupon for their local pizza supplier, whoever that may be. And so in this case, we were trying to entice Larry Ellison back to our site, and we offered him the latest James Bond movie with a large pizza from Pizza Hut in order to entice him back. Now, everything you saw us do there today as part of the demo and everything I've spoken about is part of Oracle's converged database. This is not a new version of the Oracle database. This is your standard edition, enterprise edition version of Oracle 19C, 21C, whatever version you may be, supported version you may be running on, and wherever you're running on it. Because unlike other database vendors where they've got specific versions or releases, whether you're running on-premise or in the cloud or in third-party clouds, that's not the case. When you're running the Oracle Converged database, all of the technologies and capabilities that I spoke about today are available wherever you choose to run it. So if you're running on-prem on your own commodity hardware, or whether you're running on Oracle's Exadata on-premise, or if you choose to run in the Oracle Cloud, Millie, Marcos, the others, they all did their demos on the free tier autonomous database that we have available for you to try. And that's always free. So once you create that instance, you can continue to play and look at all of these technologies on that free cloud database for as long as you want to use it. And of course, we also offer our cloud at customer offering as well. One where you get all the advantages of a cloud database model. So the pay per use, the auto scale, all of that, but all of the infrastructure and all of the data, more importantly, stays inside your data center behind your firewall using our Exadata Cloud at customer capabilities. So just to summarize what we looked at today, we want to make it incredibly simple for you to be able to build these data-driven applications. We want to offer you synergistic data technologies to support all of the latest development methodologies, whether you're using microservices, event processing, API-driven development, or even low-code development. Because remember, we have our built-in Apex development environment with every Oracle database. And you're able to do that by using our converged database with support for all the different data types and different data models. And not only do you have the support for those, but they've actually been engineered to work together to be able to store JSON documents with relational data and spatial data all in that same data, or sorry, in that same table, not just the same database. And that being able to run simple SQL or REST APIs across all of those different data models gives you much better data synergy and much better insight into your customers. And of course, because it is the same converged database, regardless of wherever you want to run it, it's much simpler to both develop and to operate these applications, because it's going to use all the same tools and techniques that you know and love about the Oracle database, standard RMAN, Active Data Guard, RAC, whatever it may be that you need to make sure that you've got a robust, highly available system. You can still do that and get all of this value out of your data. So things for you to try next. If you liked this story that you saw there, but you really want to do it yourself, we actually have a free Oracle Live Lab available for you to do exactly what we showed you here in the demo, to go through the MovieStream data set and to go through that marketing campaign creation, see all of the SQL that was actually used in more detail. No problem, just head over to our live labs to do that. If you liked any of the technology you saw there and you want to do a deeper dive, 1 hour deep dive webinar on any of those subjects with one of those subject matter experts, don't hesitate to reach out and let us know, or just schedule a follow-up meeting with your account team. They'll be able to help you with that too. For now, though, I want to thank you so much for your time. Really appreciate you joining us today. And with that, I will let you guys go. Thanks so much for joining.
You're
I
on
think you're
mute,
muted.
Monica. You're muted there, Monica. Better.
Thank you. So I was just thanking everybody. Thank you, Maria, NYOUG, Coleman, and all of our attendees today. You do get a slide deck and a recording of today's session. Just be a little patient with us till it's all ready to go, and you'll see that in your email.
And I
Thank you,
did
guys.
just post the link to the live lab in the chat as somebody requested. So, and we'll make that available too as part of the package for you.
Yes, perfect. It'll be in the email. So thank you all. I'm so glad you guys could make it today. I know everything is virtual and webinars are one after another. So we are very thankful that you continue to join us week after week. So I hope you all have a great week. Thank you so much.